A lot of you guys were complaining when you saw how thick this packet was, so yeah, I'd already planned we are going to split this up into 2 days. So I have one video tonight and another one following this up. We're just talking about angle bisectors. We're still talking about triangles. Our objective today is we're going to prove and apply theorems about perpendicular bisectors. We've talked a little bit about those before. We'll get more in depth today in next class. Some vocab we have to know. Equidistant, it's kind of in the name. It's when a point is the same distance from one or more objects. So let's say you're standing on the 50-yard line of a football field, or at the center of a soccer field. You would be equidistant from both goal lines and both soccer goals. Locus is a set of points that satisfies a given condition. Again, we'll talk more about that in class. The stuff we got to get down. Perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if I have this picture, using the marks, I know that XY is congruent to AB. Tells me right here in the picture. And if I know that XY perpendicular to AB, and I know that YA is congruent to YB, if I know this is true, again, but looking at the picture, I can tell these are perpendicular, these are the same, then my conclusion is that XA is congruent to XB. They are the same distance. They are equidistant. X is equidistant from A and B. The flip side also works if I want to work the other way. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So again, looking at this picture, I can tell that XA is equal to XB, and if that is true, then XY must be perpendicular to AB, and YA must be congruent to YB. Again, we'll have more examples in class. Just think about what this stuff means. There's some separate problems on the back. Again, before I show you answers, think about how you would go about solving these, using what we just talked about. So here's my picture. It's kind of off the screen. There it is. And it wants to know what YW is. Notice this is perpendicular. Notice these are congruent, so that means this must be the perpendicular bisector. And so WX must be W must be equidistant from X and Y. So if it's 7.3 from W to X, it must also be 7.3 from W to Y, because these have to be equal. Another problem, they want to know what BC is. So again, I know these are equidistant. A is equidistant from B and C because it's 36 to both, which means this must be the perpendicular bisector. So if it wants to know how far it is from B all the way to C, well, if this is 16, BD must also be 16. BD must be equal to CD. BD is 16, so BC must be equal to 32. It's got to be 32 all the way across. Another example, they want to know what PR is. Again, I know I have a perpendicular bisector because this box tells me this is perpendicular. These two tick marks are telling me that these two sides are congruent, which means RP must be equal to RQ. And I set it up, and you can see my algebra, and there it is. We solve for n. N is 27 over 5. We plug it back in. PR must be equal to 2 times 27 over 5 plus 9. And that's as far as I feel like going on that one. That's a sufficient answer for me as far as my notes. Now we're using this picture. Again, try doing it on your own. Think about what you would do in this picture. It says, given that LN, so we're told that L is the perpendicular bisector of DE. And we're also told that EG is equal to 14.6. Well, again, I should know it's equidistant. So I should know that EG is equal to DG, because it tells me I have a perpendicular bisector. And so if that's true, then 14.6, which is EG, must be equal to DG. So I know that DG's got to be 14.6 also. And the next one, given that DE is equal to 20.8, so it's 20.8 all the way across, DG is 36.4, and EG is 36.4. So they're telling us that these two sides are the same. And again, if they're telling us these are the same, they must be telling us that this is a perpendicular bisector, which means these two must be the same. And so if it's 20.8 all the way across, what does EF have to be? It's got to be 20.8 divided by 2, which is 10.4. Okay, let's keep going. Angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So for example, the picture tells me that APC is congruent to BPC, so this is an angle bisector. So then AC, how far is it from A to C, must be equal to how far it is from B to C. And we'll see the flip side here, works the other way too. If a point is on the interior of an angle, is equidistant from the sides of the angle, then it is on the bisector of the angle. So this picture is telling me that AC is congruent to BC. If that is true, then this is the angle bisector, and APC must be congruent to BPC. Sorry about that. So what do some problems look like? So they tell us, slide over, they tell us, given that ABC is equal to 112. So I know that ABC is 112, but I know that these are the same. 74 here, 74 here, which means this must be the angle bisector. And so if it's 112 ABC, ABD is half of that. So the measure of angle ABD has to be half of the measure of angle ABC, which is 56 degrees. TSU, try this on your own. I'm told that, again, these two are congruent, which means they sit on the angle bisector, which means these two angles must be the same. So 5z plus 23 has to be equal to 6z plus 14. And if you work out your algebra, you will get that z is equal to 9. Plug that back in, and you'll get that the measure, because they wanted TSU, the measure of angle TSU is 68 degrees. And one more. We're told that YW bisects XYZ. We're told that WZ equals 3.05. But we should know that WZ has to be equal to WX. It's equidistant. So then 3.05 has to be equal to WX. It's the same. This is one more sheet, and then we are done for this part of the notes. Lesson objectives. We're going to prove and apply properties of perpendicular bisectors of a triangle. Vocab. Concurrent. When three or more lines intersect at one point. That's what it means to be concurrent. When three or more lines intersect at one point. The point of concurrency is just that point where those three lines hit. So whenever I have three lines that intersect at one point, that is called the point of concurrency. And the circumcenter of the triangle, kind of a big word, point of concurrency of the three perpendicular bisectors of a triangle. So if I have a triangle and I draw in the three perpendicular bisectors, where they hit, where they meet, is called the circumcenter of the triangle. And what does it mean to be circumscribed? It means that every vertex of the polygon, triangles in this case, lies on the circle. Again, we'll talk more about this in class. Picture of what a circumcenter is. The circumcenter of a triangle is equidistant from the vertices of the triangle. So if I draw in, look, my three perpendicular bisectors, and they meet right there at P. So that is my circumcenter. Notice the circumcenter is equidistant from the vertices of the triangle. So PA, how far is it from P to A, is the same as how far it is from P to B, and how far it is from P to C. Those are all the same. And we'll talk more about it in that class as well. Just the circumcenter can be inside the triangle, outside the triangle, or on the triangle, just depending on the kind of triangle that we have. And I've got an example down below. It says find the circumcenter of RSO with vertices -5, 0, 1, 4, and 1, 0. So I drew in the pictures. Here's R, there's O, and there's S. If I draw in this perpendicular bisector, and I draw in this perpendicular bisector, notice where they hit. They hit on the triangle. So this was a right triangle, and notice what happened. They met on the triangle, and my circumcenter would be -2, 2. So again, we'll talk more about this stuff in class. I just needed you to be familiar with it before I see you next time.